So what we're going to do is we're going to find all the solutions. Now, what does it mean to be a solution? A solution are all the numbers such that when I square that number and then I add 2 times that number and then I add 5, I get 0. So you may be starting to wonder, like, how are you going to do that and get 0 when everything is positive? You're going to square something, it gets positive, and then you're going to take 2 times something that this could be negative, and then you're going to add 5. How do you get 0? Now visually, I'll show you what this looks like. And actually I'm going to use Desmos. So on Desmos, I typed in the quadratic, I forgot you can't type in equals 0, and notice here's what it looks like. The plus 5, all that tells me is the y-intercept. X squared being positive, 1x squared, that means it opens up. And so to be a solution is, when does this parabola cross the x-axis? And you may be thinking, it doesn't. This will never intersect this, the x-axis. Well, it does, but not in a real number system. In the complex number system, it does. And I'm not going to go into the details of that. But anytime it looks like this and it doesn't cross the x-axis, that means the solutions are imaginary. And the only way to find the imaginary solutions is by factoring. But most people find the solutions by using the quadratic formula. So what we're going to do is we're going to take the quadratic formula, and it's going to end up with the square root of a negative number, and we're going to change that to I, and we're going to get the solutions that way. So I have the quadratic formula, and I'm going to go through and say, okay, this is standard form. A is the number in front of x squared. So what number is in front of x squared? That would be 1. So I'm going to first say that A equals 1. And so that means in my formula, where I see an A, I'm going to put a 1. So I'm going to put a 1 here, and I'm going to put a 1 here. My next part, notice bx. So b would be 2. So anywhere I see a b, I'm going to put a 2. I'm going to put a 2 here. I'm going to put a 2 here. Remember, when you square, you should use parentheses. And that's, I'm going to put the value of 2 here and here. And then notice plus c. C would be 5. Now the c is only in one part of the formula. It's just right here. So instead of c, I'm going to put 5. So I'm going to do something called substitution, and I'm going to put negative 2 plus or minus square root of parenthesis 2 squared minus 4 times a is 1 times c, which is 5, divided by 2 times a, and a is 1. So I'm going to take all that and I'm going to write it down. So the solutions are, you take negative b, b would be 2, so it would be negative 2, plus or minus square root, take your b and you square it, minus 4, and I'm going to substitute a, which is 1, and c, which is 5. And I'm going to divide that by 2 times a. A is 1. So all I used so far was substitution. The first thing I would do when I'm following the order of operations, please excuse my dear Aunt Sally, is I would do anything that's in grouping first, otherwise known as parentheses. And so I really need to do this part first. I need to do that before I take the square root. So another thing you need to remember is that you're going to do exponents first, and then multiply, and then subtract. Do not subtract before you multiply. You would be breaking order of operations. So I could kind of do this in my head. 2 squared is 4, and then I'm not going to subtract yet, so 2 squared is 4. 4 times 1 times 5 is 20. So this is 4 minus 20, which is negative 16. So this is the square root of negative 16. Now, if you're not very good with doing that kind of stuff in your head, there is a calculator out there on Desmos. If you go to Math Tools, there's a scientific calculator. And don't type in the square root, but you could type in 2 squared minus 4 times 1 times 5. And notice Desmos is smart enough, they know the order of operations, they also get negative 16. So that's another option if you need it. So let's see what I have now. I now have, the solution is, the x-intercepts are negative 2 plus or minus square root of negative 16. 2 times 1 is 2. Now, spoiler alert, I knew that this was going to be negative. I knew that was going to be negative because we knew our solutions were imaginary. And to be imaginary, that means there's a negative underneath the square root. So now let's think of the square root of negative 16. How does this simplify? Well, the negative comes out to make an I, and the 16 comes out to make a 4. So this becomes just 4i. So I get the solutions are, the x-intercepts are, the roots are, all mean the same thing, negative 2. And I forgot to mention I did do 2 times 1 to get 2. I went ahead and did that part. So I get negative 2 plus or minus 4i divided by 2. Now the reason why we have plus and then minus, plus minus, that's how we get our 2 solutions. Every quadratic has 2 solutions. Either they're both imaginary, they're both real, or they could be the same solution twice. This does simplify if you have a fraction. So we have negative 2, we have 4, and we have 2. If you know a number that divides into each of those, go ahead and simplify them. So I see that 2 divides into 2, 2 divides into 4, 2 divides into 2. So I'm going to divide everything by 2. Negative 2 divided by 2 is negative 1. Four divided by 2 is 2. And 2 divided by 2 is 1. And you don't technically need over 1, so you can just say the solutions are negative 1 plus or minus 2i. And what that means is, that means negative 1 plus 2i. It also means negative 1 minus 2i. Now I'm kind of lazy. I don't like to write it twice, one with the plus, one with the minus, so I stop here. Because this means this. It means the same thing. So I just found the solutions to this quadratic, the x-intercepts, are negative 1 plus 2i and negative 1 minus 2i. Now on your calculator, if this is a perfect square, which ours is a perfect square, it's 16. We know this is 16. Now if it's not a perfect square, it's going to spit out a decimal, which I am not okay with. But because this works out to be 16, you could type it in. Notice I put the numerator in parentheses, and I put the denominator in parentheses, and I got negative 1 plus 2i. Notice that is what we got a second ago. negative 1 plus 2i. And then if I wanted to get the other answer, I'm not going to type all that in again. There's a way to get the answer to come back up. If you go second enter, it pulls it back up again. I don't have to type all that in again, and I could just go change that plus. I'm trying to change this plus to a minus. And I should get the other answer. Negative 1 minus 2i. So if you have a TI-84 and what's in here reduces, and it's a perfect square, you could just use the calculator.